Caught in the dark? Trapped in the chasms of your mind? Looking for wholeness, yet narrowed by ignorance? You lack cybernetics, the science of cycles. Cybernetics is hard to understand. It explains complexity and wholeness, an insight to free you from darkness, carry you into the daylight of a purer reason. Science has to take the broad view, to think laterally, to see complex problems in the round. But before cybernetics, science was ill at ease with complexity, content with the simple logic of cause and effect. That narrowed what it could do, made it think in straight lines. Yet linear thinking is little help in a world where lines are rarely straight, where things flow in circularities and cycles, moonrise and the ebb of the tide, breeding time locked into the cycle of the sun. Our world is full of strange twists and forces. Cycle interlocks with cycle to create great dynamic systems. Cybernetics asks a deep question about them. What mechanism is common to all cycles, from trees to machines? That mechanism is information, instructions. The beam of the steam pump tells the piston what to do. The piston tells the beam when it's done it. Cycles talk to themselves, a concept people have always used unknowingly. It took cybernetics to clarify it, unlock its power. All theory gives you power. Victorian theory about energy helped them change the world. The deeper the theory, the greater the power. But every theory is ultimately a dead end. Science must always begin again with deeper questions, and deep questions often have childlike answers. Who'd have thought cycles talk to each other? Cybernetics puts mystery back into the world. The Victorians missed the deep question, overlooked the mystery, even misunderstood the nature of the cybernetic gadget they bolted to their engines to control them, the governor. The engine speeds, straps fly apart, pushing down rods to shut the valves. When it slows, the engine tells the governor it has done so by pushing the rods back up again. The governor controls the engine by issuing instructions. A machine becomes self-regulating. But rods aren't the only things to carry instructions. A hormone can, or a protein, an electron, or a beam of light. With this insight, science is at ease with circular logic. It also sets technology free. At the Cybernetics department at Reading University in England, they make filters for space probes. Layers of material are condensed on top of each other. Each layer is only a few thousand molecules thick, and you can't measure that with a ruler. So what can measure molecules? A beam of infrared light. It's shone on the filters as they're being laid down. Some is absorbed, some reflected. How much depends on the thickness of the layer. If you can measure the amount of light returning, you also have a measure of the layer's thickness. You can then control the cycle and shut it down. Few people have the experience to make instruments able to measure energy at this level. The reason the filters are made here and nowhere else. Instrument physics, too, is part of cybernetics. The filters are fitted to telescopes in space probes. They sift infrared energy, letting only given wavelengths through to the instruments which analyze them. Everything gives off energy, even dead places like Mars. It can tell you about the chemical makeup of space, the solar system, even about life elsewhere. Cybernetics is the science of whole systems. And since everything is part of a system, from atoms to galaxies, it's universal. Our bodies are cybernetic systems in their own right. Consciously, we don't know how we walk. Nerves shuttle instructions between body and brain to keep us balanced and moving. Cybernetics lets us externalize these instructions, make them medically useful.
Okay, now I want you to just relax the arm for now, and then as you bring it forward, I want you to tighten the muscle so that this machine makes as much noise as you can possibly make. Off you go. That's brilliant. Well done. Very good. And relax. That's good. And now move it forward.
Dr. Karen Fisher helps a patient with an odd problem. The girl dislocates her shoulder whenever she lifts her arm. A muscle is too weak and needs strengthening.
Good. Okay. And now try again, tighten, move it
Consciously,
forward,
she doesn't know which muscle to tighten, but a machine can be wired into the circuit, carrying instructions between muscle and brain. This information is turned into an image on a screen. The screen shows her when she's clenched the right muscle.
Very good. So you can see by the number of green dots there that you've succeeded in keeping the muscle tension within the correct range.
Okay, what we're going to do is put this pad under your heel on your right foot. What I want you to do is to take all your weight onto your right leg, and you see the light comes up onto the number 9.
Yeah.
It means you're fully weight bearing through the leg. Okay, hold on again.
Likewise, with the lady learning to walk again. Consciously, she doesn't know when she's taken the right step. The machine knows, however, and lights up when she gets it right.
Fully weight bearing on that leg.
Yeah.
All right.
Okay.
So every time you take a step, that's the amount of weight you take through your leg.
Yeah, I see.
So what I want you to do now is just to step forwards.
Nerves in the feet tell the brain what pressure we're exerting. But after an illness, the brain can forget what the right pressure feels like. By externalizing the body's inner circuits, the patient is shown how much weight she must put on a leg to straighten it without strain or damage. The bleep, too, tells her she's got it right. Cybernetics doesn't see a human body. It sees a system controlled by instructions, an abstract principle which lets it tackle any problem. It gave Andrew Crow mobility, even though he's almost totally paralyzed. All he can move is his left arm, but that's enough to send an instruction. A secondary system carries it to the brute mechanics of the car. Back for stop, forward for accelerate, right for right turn.
What speed are you doing now? That's right. Okay, carry on.
From the outside, he's like any other driver. Only when he gets out do you notice he's badly crippled. But cybernetics can help even here. The van on the test track in the south of England is unique. The driver talks to it with an infrared remote control. The signal tells the van to open its door and lower its lift. Cybernetics means almost everybody can now drive. People with broken spines, arthritis, polio, multiple sclerosis, even brittle bone disease. Cars for the disabled have been around for 40 years. Usually it meant bolting on bits of ironmongery. Cybernetics helps engineers make controls specific to each weakness. Perhaps you only need a handlebar to control braking and acceleration. Not long ago, the cyberneticians at Reading were asked to adapt a car for a thalidomide girl. She had no legs and only a stump of an arm. To the scientists, it was an abstract problem in communication. Hydraulics, driven by the engine but sensitive to the slightest touch, were made to carry instructions from the girl through a joystick to the car. Overnight, it revolutionized car controls. The van is in an unbroken line from that original insight. We're riding a crane into a man-made world where matter is moved without a man in sight. The crane flies by storage bins in the warehouse of one of the biggest automated diesel engine factories in the world, Perkins of Peterborough, in the east of England. A computer tells the crane which bin to pick from the rack. Then the computer tells the crane to take it to the gate of the warehouse. Millions of parts are stacked here, ordered, stored, retrieved, untouched by human hand. The computer orders a robot to meet the crane at the gate of the warehouse. It's a self-contained world, inconceivable without the cybernetic concept. Like all systems, it needs information to keep it running. Instructions flash along electronic nerves from a hidden computer. The computer orders the crane to give the bin to a robot, then tells the robot where to go. Crowds of robots mill and pirouette, kept in line by a delicate web of orders. They glide and swivel to a computer's tune. Only a computer can control such complexity. Mock life, proto-life, in a barren world. A machine world. People and robot meet only on the assembly line. Even here, people are scarce, needed only for jobs still too hard for machines. Machines now oddly resemble men, all arms and fingers. Behind, hidden, the computer knows all, controls all. As a governor controls a steam engine, so a computer controls a factory. of light replace eyes, questioning the fit of piston and cylinder. Precisely, unhurriedly, machine moves machine. It's a time world all of their own. Yet an engine is completed every 2.5 minutes. Skeletal arms reach out, pick up, slot in bits of engine. Control, communication, information, feedback. The classic definition of cybernetics. The science of cycles and wholeness. The entire factory is a cybernetic entity, greater than the sum of its parts. At last, a completed engine is shoved off the line. All those parts delivered by robot at the beginning of the line are now bolted and slotted together. In place of a box of bits, we have a new cybernetic system, a working motor. It too is greater than the sum of its parts. In the testing bay, a computer will question the engine, examine its gases, speak to its pistons. People are unwanted even here. Cybernetics is a way of seeing in the dark, of probing the chasms of our ignorance. It gives us an insight into how things work. Motion can be read as a message, for example. A shock wave is information. An 18th century cottage, a 20th century factory. Kansen Gurop, once a student at Reading, makes the seismometers which monitor the test ban treaty between the superpowers. Arrays of instruments are lowered down boreholes and locked into place. Midway hangs the seismometer. On the surface is its computer. In the seismometer is a pendulum. An earthquake makes it tremble. Electronics supply an equal force to keep it still. Earth and electronics are in dialogue, talking to each other. The pendulum is the go-between. The force needed to keep it still is also a measure of the force of the earthquake. A microchip turns the force of the earthquake into a reading intelligible to a human. The Earth is full of strange forces. What keeps the world cool while the sun gets hotter? Why does the amount of oxygen in the air stay the same? Why doesn't the sea get too salty for life? James Lovelock thinks it's because the Earth itself is a self-regulating cybernetic entity. As the governor controls the engine, so life controls the planet. He calls it the Gaia hypothesis, after the Greek goddess Mother Earth. Some time ago, NASA asked him to make an instrument to look for life on Mars. What is life, he asked, and nobody knew. Out of that simple question came the Gaia hypothesis. It tells us Mars is dead.
My reasoning went like this. If there was life on Mars, it would be obliged to use the atmosphere as its only available mobile medium, as a kind of conveyor belt for raw materials and also for its waste products, and that such a use of the atmosphere would change it chemically and render it different from the atmosphere of a dead planet where everything is close to chemical equilibrium. Well, when we looked at Mars with an infrared telescope in the late 1960s, what we found was a planet with an atmosphere that was very close to chemical equilibrium, and therefore, according to this theory, it should be dead. And the extraordinary thing is that the Earth's atmosphere is utterly anomalous in the solar system. It's an atmosphere which is wildly out of equilibrium. Indeed, you could say that the Earth radiates so strong a signal of light in the infrared that you could detect it in a spacecraft way outside the solar system.
Martian chemistry is flat. Molecule ignores molecule. But Earth is odd, defiant of the laws of chemistry. Molecules build themselves into people and trees. Molecule talks to molecule, making the whole world interactive, interlocked, alive.
This equilibrium in the Earth's atmosphere is due to the presence of highly reactive gases, gases like methane and oxygen coexisting. That's an almost impossible state of affairs if you think about it. A mixture of methane and oxygen is a bit like the gas mixture that goes into the intake manifold of your car. It's something that if it were more concentrated would be explosive. And the fact that it stays there at steady state means not only that you have life on the planet, but also that somehow the life is regulating what is an unsteady mixture. In other words, keeping it constant at a steady state.
Life cradles the planet, holds its unlikely chemistry in check, balances its gases, keeps us all from slipping into chaos. Cybernetics tells us how it works, yet it is still hard to see the wood for the trees.
Most science, even today, still operates on the old Aristotelian cause and effect logic. And this, I think, is why Gaia is so difficult for most people to understand, along with most cybernetic systems. There is a story that James Watt's governor was shown to Clerk Maxwell in the last century, and he was one of our best physicists ever. And he said he'd had 3 sleepless nights trying to analyze the operation of Mr. Watt's steam engine governor. Although he had no doubt that it worked, the mathematics of it defeated him. Cybernetics is rather like this. It's very difficult to understand. In fact, I doubt whether you can do most non-linear cybernetic systems analytically at all. If it weren't for computers, we wouldn't even start to understand them.
Cybernetics has one last great gift for us, a warning. We could be tearing the world apart, making it more like Mars, all dry stone and windy places. Cycles are stable only while they're intact. Take too much from them and they collapse, bringing the whole of life crashing down in chaos and ruin.
By about the year 2000, we will have cut something like 65% of the total humid tropical forest. Beyond somewhere between there and 80%, it's likely that the whole system will crash. And when it does, about 1 billion people living in the third world will be precipitated into desert conditions like those of the Sahel. This will be a human disaster worse than an all-out nuclear war. And I think this is something that we should consider more seriously than anything else on the environmental scene.